Good evening, good afternoon, or good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor Sydney live stream and event and another episode in our Devs Downunder series. I would like to welcome back Darren Robinson. Hi Darren. Darren has 25 years experience as an IT professional working for global integrators. Darren has specialised in directory services in complex, heterogeneous environments and identity management. He is currently a principal consultant and the principal identity and access management architect at Microsoft Purple. And he is also a Microsoft MVP. This session today will be about 45 minutes for the session and about 10 minutes for questions at the end. Do send us your questions in that comment section or the Q&A if you're on YouTube Live or Learn TV, and we will try and answer as many of those as possible at the end of the session. We'll also share with you a link to the feedback survey, and you will also see this one go straight to our YouTube channel after the session. So if there's anything you missed from today, you can go check out the on-demand version straight after this. You'll also see I added in there the check-in page. So the check-in page holds a whole bunch of additional resources that Darren has shared with us today, and also just our Microsoft links as well. So just links to that YouTube channel and our meetup page for future events and that survey as well. Please make sure you enter in that event code, which is 14031 for today's session. But without further ado, I'd like to hand the floor over to Darren to begin the session for this evening. So Darren, thank you, and over to you.
Thanks, Sarah. Yes, welcome to my session, Digital Identity. Are we there yet? As Sarah said, I'm Darren Robinson. I'm a Principal Identity and Access Management Architect with Telstra Purple, based in Sydney, Australia. The slide deck from this presentation will be available after the session on my blog at darrenjrobinson.com, and the recording of the session from the Microsoft Reactor YouTube channel will be embedded in that post. So if you're looking for any of the content, you don't need to screenshot it as we go through. The full deck with the majority of the narrative that I talk through on each slide will be available. So what is digital identity? If you were to ask that question to 10 identity management consultants, you would likely get 11 different answers, and many of them will be very technical. I like to think of a digital identity as the merger of our physical identity and our associated physical identity-related documents, essentially electronic representations of your physical identity and your physical biometrics, such as face and fingerprint, along with a set of claims. Claims, think of your first name, last name, address, age, citizen ID, tax file number, etc. Many of us will have a concept then of what digital identity is right now, but how did we get to here? If we go back in time, before the internet, around about 25 years ago, our digital identity was very rudimentary. Computer systems had evolved to a point where they were multi-user. In order to distinguish between users for access and security separation requirements, the concept of a user ID and a password were implemented. This originally came from host-based systems, think mainframes in the 1960s. Now, for most of us, we skipped that era and we were introduced to accounts and passwords in order to access PC-based computers and in a business setting on a corporate company network. Our account was created by an admin on each resource we needed to access, and we needed to sign in with that user ID and password. Local area networks were typically local to a building. To access systems, you needed to be physically present or dial into that office using a modem connected to a phone line. For larger organizations, there were host-based systems such as AS400s, OS390, and DEX VAX-based systems that were centrally located. You would use a text-based terminal emulator over a wide area network to access them. You would then log in again with a username and password. The wide area networks that connected the office typically weren't very fast and were using technologies such as X25, ISDN, and frame relay. The corporate wide area networks provided the necessary connectivity between offices to allow access to the centralized host-based systems, such as these mainframes, as well as for post office messaging replication for email delivery within the corporate network. All communication, though, was within an organization. In the 90s, we saw the proliferation of PC-based networking and the introduction of directory services in PC-based environments. No longer were we needing to have an account on each individual network server, but a single account in a directory service with permissions to access distributed resources within the network. Novell, hugely popular in the 90s and early thousands, started with NNS, Netware Name Service. NNS was a synchronization of individual Netware 3 binary accounts databases to a centralized directory service that was then superseded by Novell Directory Services and then eDirectory. Lantastic, IBM OS2, Banyan Vines, DEC Pathworks, and SCO Unix were also very popular in this time before Microsoft entered with Windows NT Advanced Server, and then later followed by Windows NT Server 4.0, Windows Server 2000, and Active Directory. This brings us to where we had numerous different implementations of centralized identity models based around corporate networks, which were for that corporate only. Each organization had a computer network. It was contained in their own data centers, and offices accessed predominantly being physically, you accessed it by being physically located in an office of that organization on a linked computer network. This was just great. Organizations owned and managed their own implementations and had full control of account management and access. Then came the internet, a common public network providing connectivity between organizations and individuals globally. What we then needed was a method to provide a level of trust between organizations for identity, authentication, and access. Enter the federated identity model after the internet. The Liberty Alliance project was formed in 2001 with vendors such as Novell, Sun Microsystems, Oracle, and Computer Associates. Some of these don't exist anymore. They've been acquired by other organizations. But these were the foundations of the first identity internet federation standards that was defined using the Security Assertion Markup Language, SAML. SAML was an XML-based and open standard for transferring identity data between two parties. This introduced the concept of an identity provider and a service provider. SAML 2.0 was ratified in 2005 as an OASIS, Organization for the Advancement of Structured Information standard, after the Liberty Alliance project donated the Identity Federation Framework specification, which became the basis of the SAML 2.0 spec. We now had a standard that would allow us to use our home realm's identity to access resources in a remote network. From an organization perspective, this was great for accessing services hosted and managed by another organization using a centralized and managed corporate identity. The same was possible for the rise of public cloud computing, now more commonly known as software as a service. Within corporate networks, this required a gateway between the corporate network directory service and cloud services. All the major vendors developed this capability with services such as Microsoft Active Directory Federation Services, Novell Access Manager, Ping Federate from Ping Identity, SAP NetWeaver, and IBM Tivoli Federated Identity Manager. Much later, we also saw this with social identity and the ability to log on with your Facebook, Google, Twitter, and LinkedIn account, etc. We're still using identity federation like this today. Kim Cameron, who was the Microsoft chief architect for identity and access for over 20 years, was the originator of the 7 Laws of Identity, which he published in 2005. The introduction to his 7 laws, in the introduction to his 7 laws, he predicted that without an identity layer, the internet had the possibility of becoming an electronic Wild West. Like the famous graphic shows on the screen, on the internet, nobody knows you're a dog. To connect to the internet, you just needed network connectivity using the internet's TCP/IP protocol. From that, you only know the address of the machine that connects. It tells you nothing about the person, organization, or thing controlling that machine and communicating with you. It could be a dog. Unlikely, but it could. In the 2000s, the first attempts were made to bring an identity layer to the internet. In early 2000, Microsoft introduced Microsoft Passport, a passport to convenience, Microsoft's single sign-on and wallet services for online shopping. At the time, this was described as a mega service available for businesses from Microsoft. Mega services were touted as a new breed of service that would extend the web's capabilities by directly linking applications, services, and devices with one another over the internet. Passport would provide online merchants with customizable and easy to implement e-commerce services that improve their customers' experience by streamlining purchasing and simplifying the registration across a network of websites and services. Whilst the intent was great, the reality was that a number of decisions by Microsoft limited its uptake, and the federated identity SAML 2.0 spec was getting a groundswell of support. Microsoft had another attempt with CardSpace, codenamed information cards or info cards, that came with Windows 7, Windows Vista, and Windows Server 2003. The premise here was a little different. An individual would create a series of personal digital identities or cards with differing claims to access services. As a user, you would select the info card you wanted to use for a given interaction. Novell supported this concept with their Digital Me product, which was essentially an identity selector for info cards in order to provide a mechanism to authenticate without needing a username and password for every website. Ultimately, the concept didn't get a lot of uptake. Microsoft announced in 2011 that CardSpace 2, that was due to ship that year, would not be shipping. The final attempt I'll mention here is Mozilla Browser ID, which did get renamed to Mozilla Persona. Mozilla attempted to embed functionality in the browser to store a list of verified user profiles, which could be used to authenticate and get single sign-on to websites. This also didn't get the uptake that was expected. Ultimately, they all failed due to a combination of reasons. There wasn't a single identity provider that would work with all applications and services. There were disparate technologies that didn't get the anticipated support, often due to some of the shortcomings of the offerings. On the federation side of identity, it's often convenient to trust a social identity provider such as Facebook because humans are lazy and it's just convenient. But what if you get banned or you want to exit the platform? Any sites you've used your Facebook identity for authentication will then not be accessible. How do you feel about using a social identity provider for authentication to services with more personal or sensitive data, such as your health or financial records? The common denominators here, the attributes to their failures, are around security and trust, effectively the lack thereof. Underpinning all those, with their well-intentions, was also still present our Achilles heel. Passwords. Passwords first used in association with a login ID with multi-user computing systems in the early 60s have evolved little since then. Passwords can now be longer than 8 characters, and are required to be longer than 8 characters, but that's for the most part the biggest change that's happened. The rapid increase in computing power and the ability to crack passwords saw the minimum specifications for password policies get a little bit more complex though, requiring special characters, numbers, and changes of case. However, with global connectivity associated with the internet and general human laziness, passwords and password policies are fundamentally broken. This meme is funny because it's true. And a summary of the top 15 passwords found in data breaches in the last number of years confirms the laziness of humans. The common passwords that are being used and are breached and their appearances in data breaches is just astronomically bad. Troy Hunt's Have I Been Pwned InfoSec side project is the representation of the reality we all need to be cognizant of. Passwords have passed their expiry date. Yes, we have multi-factor authentication, but that is a temporary band-aid on top of a broken system. Since launch in 2013, Troy has personally loaded 546 pwned data breaches into Have I Been Pwned, totaling over 11 billion accounts. Datasets such as these are used extensively in one of the most common attacks on computing systems, the password spray attack. A password spray attack is where a common list of passwords, often obtained from a data breach, is used in conjunction with an account list, also often obtained from a data breach. The two are combined and each password is attempted with each account, hence a password spray attack. This graph is from 2019 from a Microsoft report and shows a pair of password spray attacks. Each color represents the hash values of failed password requests. The hills, not the spikes, but the hills indicate multiple failures on the same hash value within that time frame. There are two distinct attackers in these examples. The hills, whereby the hackers try 45 distinct password attempts at around 4,000 accounts per hour. The spikes try 15 distinct password attempts on around 10,000 accounts per hour, running over a period of 2 weeks. The point here is, this is the most common of attacks. And unless you have mitigations in place to detect and block such attacks, accounts will be compromised. If you take nothing else away from this presentation today, enable multi-factor authentication on all of your accounts. Looking up our email addresses in Have I Been Pwned enforces that if you interact on the internet for any length of time, the likelihood that you will have credentials in a data breach is almost inevitable. Complete transparency of your vulnerability is available using common password managers, such as 1Password. Leveraging integration with Have I Been Pwned, password managers such as 1Password can alert us if we're using a vulnerable password, where we are reusing a password, or even if there's been a compromise in a website that we have stored credentials for. Having a separate login for each system or service you access with a strong password in a password manager along with MFA is your current best minimum account security posture. So moving forward then, password have passed their use by date. Multi-factor authentication is a band-aid on top of passwords, providing an extra skin of protection on top of your account. Don't get me wrong though, enable MFA on all of your accounts today. But the use of more advanced authentication solutions such as authenticator apps, one-time password apps, and hardware tokens is much better. We need to be actively striving to say goodbye to passwords, log in with biometrics, enrolled credentials, and passwordless authenticators. Does it sound a little too far-fetched? I was a little skeptical, but eternally optimistic when I was sitting in the front row of the Cloud Identity Summit in Chicago in 2017, and Alex Simons, corporate vice president in the Microsoft Identity Division, set a goal in his keynote for 1 billion logins without passwords by 2018. I'm not sure if that goal was achieved in 2018, but in mid-2019, Alex was indicating more than 85 million authentication events per month were being processed to Azure Active Directory using passwordless methods. Now in mid-2021, Microsoft are currently running a pilot with some of their senior executive staff, such as Mark, the Chief Technology Officer of Azure, whereby they switched up the authentication policies to require the use of password mechanisms. More importantly, whilst there's still a password in the directory service, it's randomized and the user has no idea what it is. Libby, who's on the identity team within the product group, along with numerous of her peers, have been dogfooding this solution for more than 6 months. We need to push passwords down the list of acceptable methods for authentication. Windows 10 supports many passwordless options, such as Windows Hello with face, fingerprint, and PIN. Additionally, FIDO2 security keys are also available. I'll talk more about those in a few minutes. Most modern laptops have the hardware required for Windows Hello, such as a fingerprint reader or a Windows Hello supported camera. However, if you don't have those, the options aren't too expensive to add on to your existing laptop. For example, the Lenovo 500 FHD webcam sells for under $100 Australian and is Windows Hello capable. Likewise, the Lenovo fingerprint biometric USB mouse is under $50 Australian and provides Windows Hello capabilities through the fingerprint reader in the top of the mouse. Moving deeper into passwordless, how do we onboard new users into our environment and enable them to bootstrap their authentication using passwordless methods? In public preview now is Temporary Access Pass. Temporary Access Pass provides a time-limited passcode that a user can use for their first authentication into Azure Active Directory, after which they can then enroll other passwordless authentication methods, such as push notifications using the Microsoft Authenticator app and FIDO2 security tokens. Microsoft Nudge is a new configurable policy setting that is also in public preview. It allows administrators to set policies to nudge or remind users who haven't enrolled with Microsoft Authenticator at logon time to uplift their authentication methods and enroll with Authenticator. Then when a user is enrolled, Microsoft Authenticator becomes their default authentication method, allowing sign-in via application-based push notifications in the Microsoft Authenticator app. Fast Identity Online, FIDO2, whilst it took a few years for the standards to be approved, tokens are now widely available from numerous vendors. FIDO2 tokens have support in Windows 10 and provide another method for passwordless authentication. Choosing a FIDO2 token can be a little daunting due to the varying options available from numerous vendors. My recommendation is to go with a biometric-based FIDO2 token, such as the Fidian or Trust Key option shown here. This is the Fidian biometric key, and this is the Trust Key biometric key. So that's the fingerprint reader there, and that's the fingerprint reader there. This one is of metal. This is the Fidian one is of metal construction for the case, and the Trust Key is plastic. The YubiKey shown on the far left, this one here, whilst it doesn't have biometrics, it does have NFC support. This YubiKey here has a Lightning connector on one end and a USB-C on the other. Makes it versatile to be used between desktop and mobile-based authentication applications. Yubico, who make the YubiKeys, have a biometric FIDO2 token coming soon. This collection on the right is my actual keyring. I've got a number of different options here, which are for different environments and different applications. But keep in mind, you don't need to have a single token for a single environment. A single token can actually contain multitudes of credentials for multiple environments. Finally, let's talk about self-sovereign identity, sometimes also referred to as decentralized identity. This is the current incarnation of the concepts previously undertaken that we discussed earlier, such as Microsoft Card Space. A key difference, though, is the authentication plumbing. Here we utilize our most modern of internet authentication protocols, OpenID Connect. The other and most important differentiator is that you as the individual own your identity in the digital world as you do now in the physical world. Using a digital wallet, such as the Microsoft Authenticator, you can store a series of credentials that are associated with organizations and institutions that are authoritative for validation and verification of aspects of your identity. Your government could issue you with a verifiable credential to verify you're a citizen of your home country. Your local state transport authority could issue you with a verifiable credential to show you have a valid driver's license. An educational institution could issue you with a verifiable credential that validates and verifies that you're a graduate with an IT computing degree from the Faculty of Engineering at the University of Sydney. When looking to access services and needing to provide proof that you're a citizen or a graduate, you can use one of your verified credentials. The service can validate and verify that it's valid and hasn't been tampered with by verifying the cryptography of the validated credentials. This is possible as decentralized identity leverages decentralized public key infrastructure to exchange and verify signatures on digital identity credentials. If the credential has been altered, then verification and therefore validation will fail. The Microsoft infographic here shows the concept as a scenario, which is supported by a short video. The links for this are in my blog post and are in the notes that Sarah's posting. But let's walk through the concepts in a little bit easier scenario. In this example, it's showing the verifiable credentials flow. In step 1, Alice obtains a verifiable credential from her employer, Woodgrove, and stores it in Microsoft Authenticator. In step 2, Woodgrove attests that the user has been validated through their identity proofing processes and creates a verifiable credential signed with their decentralized identifier and the user's decentralized identifier in the subject. Alice signs a verifiable presentation with her decentralized identifier and sends it to the verifier, which in this scenario is Prosware. Prosware then validates the credential by matching it with the public key placed in the decentralized public key infrastructure. Here is a more detailed version of what's in behind those cards and those processes. It shows that the credential, which is a JSON web token, contains the issuer, subject, and claims associated with the verifiable credential. Instead of using blockchain for cryptography, though, blockchain is used for the decentralized PKI ledger for verifiable credentials. Now let's have a look at a demo on what that actually looks like. This is a walkthrough of actually issuing and validating verifiable credentials using the public preview of Azure Active Directory Verifiable Credentials. Using a web browser, a user lands on an enrollment page of an issuer's website. They hit the Get Credentials button, and they scan the QR code using the Microsoft Authenticator application. You can see in this graphic here, currently there's no credentials. You click on this little link here to scan the QR code. In this case, I didn't already have an account with Verifiable Credential Experts, so I need to sign up to get one. I hit the sign up now, and I go through the process of registering with Verifiable Credentials. In this scenario, I'm just providing some data about myself, like an email address, a password for the account, my given name, and my surname. In this example, there's no verification or additional validation of my identity, but in a real world, there'll be additional steps here for appropriate identity proofing. Once signed up and signed in, I'm issued a verifiable credential. I can now add this to my Authenticator, into my credentials wallet in Microsoft Authenticator. The issuer of the verifiable credential also stores a record on the decentralized public key infrastructure that can be later used to validate through decentralized public key infrastructure my verifiable credential. So let's have a look at that and have a look at that flow. I go to a website to access information and services that I'm allowed because I'm a verified credential expert. That site will ask me to verify that I'm entitled as a verified credential expert. I hit the verify credential link on here and I get a QR code again. I start the validation by scanning the QR code and providing my verified credential from my wallet. So I already have a verified credential. I allow the website to have the verified credential, as well as the claims that are associated with it. The validation is validated using the decentralized PKI infrastructure that's provided by verifiable credentials. In my wallet, I can then see, well, I then get access to the Verified Credential Expert website and whatever the entitlements are that I'm accessing. From my wallet, I can see that the credentials were provided and presented, and also what they actually contained. So I can see a log of how my identity was used, as well as where it was used. There are many more details associated with how this all works under the covers, but the key concept of self-sovereign identity is that I own the identity and I control the use of that identity. In terms of real-world solutions, there are a number of concepts associated with self-sovereign identity because it's been in development for over 5 years, and there are already a number of real-world implementations. Here are logos of just a handful of vendors with solutions or products using self-sovereign identity and implementations similar to verifiable credentials. Some of these solutions target the consumer market, whilst others are for industry verticals such as healthcare or citizens or governments. Thinking back to the original question though, digital identity, are we there yet? In my opinion, I say almost. We've come a long way in the last 30 years. We've been optimistic in solving the problem in the past, but have also benefited from failing and learning from past shortcomings. Users are and should be the center of their own identity. Solutions are being built on top of existing technologies and protocols. not where we've been before, having to build the plumbing as well as the solution. But there are still a few items to be considered. Will we have a reliance on digital wallets? The reality is we'll have multiple digital wallets. Just as now we have multiple authenticator apps and MFA methods. Will they all be tied to our mobile phone? What happens if we break or lose our phone? How do we go about identity recovery in scenarios like that? What about portability of verified credentials? Will I be able to travel across geographies and have a level of transitive trust to honor verified credentials from remote issuers? For example, governments trusting governments. How will we treat minors and having guardians to manage their dependents' digital identities until they reach age of majority? How will we enable the ability to transfer guardianship of identity for afterlife scenarios? For example, a few years ago, I needed to prove heritage of my father and my father's father. However, they are both deceased. I needed to acquire and provide notarized paper-based documents to validate that heritage. How do we do that digitally for deceased entities? And finally, what about the growing threat of deep fakes? How will we protect implementations from those with malicious intent generating fictitious identities? I personally think we're a lot closer to succeeding than we previously have been, and I look forward to bringing these technologies to the mainstream. I'm going to switch over now to see if I can see if there's any questions.
Awesome. Thanks, Darren. Just quickly having a look at that Q&A section there, the comments. We haven't had any questions come through, but we will give everyone a couple of minutes to put those questions in the questions section there, which we'll keep an eye on. In the meantime, oh, there you go. A question come through from Andrew. How do we keep up to date on this regarding identity?
The preview and all the technologies associated with decentralized identity and Azure AD Verifiable Credentials is all open source. So Microsoft is providing the mechanisms and that underpin the technologies that they're building. And that's all available on GitHub repos, and there's a community building around it. There's a link that's in the bottom of my blog post, which will be going live in a couple of minutes, that has linked to some of the tutorials around that, which also has links to the GitHub repos. There's also the ID 2020 Alliance, which Microsoft is doing with other vendors to support the over 1 billion people that are without a country and without identities because they've been misplaced through tyrannies of war, changing borders, and disasters, natural disasters globally. They're using these technologies of decentralized identity to issue them with new identities, which are then verifiable using this technology. So that's something that's about 3 or 4 years in as well, to looking to solve that problem with decentralized identity. If you look into the Identity 2020, there's also up-to-date information around how that's progressing and where that's going as well. I hope that helps.
Great, thanks, Darren. We'll give everyone another minute. Just Anish says this link isn't working. Anish, if you want to just expand on that and let us know which specific link isn't working, that would be great to see if we can give you a more updated link. In the meantime, just a reminder to everyone to check in for today. So all those additional resources Darren spoke about and I spoke about at the beginning are in that check-in link. Oh, the reactor check-in link isn't working. Let's try that again. You know what, I think it's just combined with the event code wording at the end there. So I'll just redrop that in. Thank you for letting me know that one. We'll just give everyone one more minute if any other questions come through. whilst I replace that link. Thank you. Okay, that is the check-in link. And if you can use the event code I'll just type it in there now, 14031. Cool, to get the additional resources. So thank you again, Darren, and thank you to everyone for tuning in. Thanks, Doc, says Lance. We appreciate everyone interacting with us in the Q&A, and for Darren for taking the time to do a live stream with us at the Reactor, Microsoft Reactor in Sydney. We hope to have you guys back again soon, and we look forward to having you back in person or another live stream. Have a good rest of your afternoon, evening, or morning, wherever you joined us from today. Thank you.
Thanks for everyone for joining.